In this video, we'll solve several dosage calculation problems in which nurse must either dilute or reconstitute a medication before administering it. Let's take a look at the first one. The order is to administer Z-Cillin, 500,000 units IV, Q6 hours. The vial reads, add 9.6 milliliters of sterile water to yield 100,000 units per 1 milliliter. So how many milliliters will the nurse administer? So let's take a look what's in front of us. We have a powdered medication, a vial with powdered medication. We need to add sterile water to it. We're going to shake it up and we are going to get a solution that will have 100,000 units per 1 milliliter. That's very important for us to know when we try to figure out how many milliliters to administer. This number here, 9.6 milliliters, many times students make a mistake using this in the calculations. This number you need when you're actually in a med room, you have your powdered medication, you're adding a certain amount of sterile water. That is the number you need to know at this point. How much water to add, then I'm shaking it up and I'm getting my solution. After that's done, to calculate the dose to administer, you need to know concentration that is a result of this reconstitution. In this case, it's 100,000 units per milliliter. Once you identify this information, solving this problem is really very easy. Using our DKP method, we're going to write, first, what do we know? 100,000 units is 1 milliliter. I'm going to write it just like that. "100,000 units is 1 milliliter. This is my is line. It's not necessarily equals, and you will see in other problems as we go that it's not going to be the same as to say it equals to. It's just is. It is what it is. I have to administer 500,000 units. I'm going to put my units under units. Is X milliliters. That's what I need to find. How many milliliters is this many units? So 100,000 units is 1 milliliter. 500,000 units is X milliliters. I double check myself. Do I have my units under units? Do I have my milliliters under milliliters? It's important to have the same measure under the same measure. Next, I find a diagonal with two numbers, and I'm going to multiply these two numbers. And this third number, I'm going to divide by it to find my X. So in this case, my X equals 500,000 times 1 divided by 100,000. And that equals to 5 milliliters. I know I found milliliters because I was looking for milliliters. I set my X as milliliters. And that is your answer. Remember, do not make a mistake trying to calculate using this number. This number you only need when you're in a med room, mixing your medication and diluting your medication. When you're done with that, you do not need this number anymore. You only need the concentration that you got as a result of this dilution. Here's our next problem, and you can see the label for this problem. And here's our order. Medication Z, we have to administer 4 milligram IV push for sedation now. And the drug reference says that we need to dilute the drug immediately before use with equal volume of diluent and inject slowly at 2 milligram per minute. And available medication is 4 milligram per 1 milliliter. That's our available concentration. And we have not one, but 3 questions this time. First of all, we need to find how many milliliters will the nurse draw up into the syringe. Second, over how many minutes will the nurse give this medication? Total, how many minutes will we be pushing? Because there's specific instructions for pushing it. And third, at what rate in milliliters per minute will the nurse push? So let's try to solve it one step at a time. First of all, how many milliliters will we draw up in a syringe? Let's go back to the order and see that we have to administer 4 milligram. And what do we have available? 4 milligram is in 1 milliliter. So we at least will have 1 milliliter of liquid in our syringe. But let's take a look at the instructions. We have to dilute the drug immediately before use with equal volume of diluent. So in addition to our 1 milliliter, we are going to have another milliliter of diluent, equal volume. So altogether, 1 milliliter of drug and 1 milliliter of diluent will give us 2 milliliters total we will have in our syringe. And that is the answer for our first question. How many mLs we'll have in the syringe? 2 mLs. This is our answer for first question. Let's look at the second one. Over how many minutes are we going to give this med? And the instructions are inject slowly at 2 milligrams per minute. How much do we have to give? We have to give 4 milligram per order. 2 milligram are going over 1 minute. Then for 4 milligrams, we're going to need 2 minutes. Now, if you don't do math real well in your head and you need to write it out, please write it out to prevent mistakes. So I'm going to use DKP method and I'm going to say 2 milligram is 1 minute. For number 2. Two milligram is going over 1 minute. And remember, this line represents just is. It's not an equal because milligrams don't equal 2 minutes, right? 2 milligram is 1 minute. Now, under that, I'm going to say I have to administer 4 milligram. And I put my milligram under milligram. And I don't know how many minutes I need to push my 4 milligram per order. So 2 milligram is going over 1 minute, 4 milligram is going over X minutes. Double check, do you have milligram under milligram, minute under minute? We're going to find a diagonal with 2 numbers in it, and we're going to multiply these 2 numbers and divide by our third number. X equals 1 times 4 divided by 2. And that equals to 2 minutes. We answered our second question. Over how many minutes will the nurse give the med? Over 2 minutes. Now we have third question to answer. At what rate are you going to push in milliliters per minute? So you have milliliters in your syringe, and how fast are you going to be pushing that? How many milliliters do we have total? 2 milliliters. These 2 milliliters are going over how many minutes? We just found 2 minutes. So I'm writing 2 milliliters is going over 2 minutes. Now I am wondering, what is it milliliters per minute? How many milliliters per 1 minute? I'm checking myself, do I have milliliters under milliliters, minutes under minutes? And then I find a diagonal with 2 numbers that are not X, multiply these 2 numbers and divide by the third number. 2 times 1 divided by 2. And that is 1 milliliter. I found 1 milliliter per minute. I will be pushing it at that rate. So this is how we answered those 3 questions of this problem. How many mLs will we draw up? 2 mLs. Over how many minutes will we push these 2 mLs? Over 2 minutes total at a rate of 1 milliliter per minute. And see, in this case, unlike the previous problem, the amount of diluent mattered because questions were different. So read your problems carefully and make sure you understand what is given to you and what is being asked of you to do. Here's our next problem. Administer medication Z 20 milligram IV push for blood pressure 70/48 once. Available 50 milligram per milliliter. That's our available concentration. Now instructions are given to dilute, mix the vial, this vial right here, mix it with 9 milliliters of flush for the final concentration of 50 milligram per 10 milliliters. And flushes come in different sizes, 3 ml, 10 ml. This is the flush that comes in a 10 ml. It's full of normal saline. How many milliliters will the nurse administer? That's our question. Lots of words here, but it's easier than it looks. Let's take a look. What is the instructions telling us? Dilute the vial with 9 ml of flush. Let's start with that. Here's my 10 ml of flush. I'm going to squirt 1 ml out of here. Now I have 9 ml. I'm going to inject all of that into my vial that's given to me, into this vial. I injected 9 mLs, and now my final concentration is 50 milligram in 10 milliliters. Used to be 50 milligram in 1 milliliter. I put 9 mLs of flush in there. Now it's 50 milligram in 10 milliliters. So knowing this concentration, how many milliliters do I administer if I have to give 20 milligram? Let's set it up as a DKP method. And we're going to write first, what do we know? We know that 50 milligrams make 10 milliliters. $50 milligram is 10 milliliters. I have to give 20 milligram. I carefully place my milligram on the milligram. Is X milliliters. I'm going to multiply on diagonal and divide by the third number. X equals 20 times 10 divided by 50, and that equals to 4 milliliters. I know I found milliliters because I set my X under milliliters. So all of that wordage here was a little too much and confusing, but all we did is we followed directions exactly how it's written. We took 9 milliliters of flush by squirting 1 milliliter out. We injected those 9 milliliters into our vial, and final concentration we got was 50 milligram per 10 milliliters, and we used this concentration to calculate our milliliters to go and administer. In this next problem, we have a label and the order to administer dankingazole 25 milligram IV stat. How many milliliters will the nurse administer? Let's carefully look at our label and identify the information that's necessary to solve this problem. The label has a lot of information on it, but the most important thing to answer this question is how many milligrams per how many milliliters is the final concentration of this medication. The label has this big number, 25 milligram per vial. This one doesn't help us because it does not provide the necessary information, milligrams per milliliters. Let's keep reading, and in a small text down here, we can see that it is 25 milligram per 0.5 milliliter. That is the essential information for us to be able to calculate the milliliters. So let's use this information and set up our DKP method. From the label, we found that 25 milligram is 0.5 milliliter. How much do we have to give? 25 milligram. Do we even need to calculate anything? It is 0.5 milliliter that we will administer. If I change the order to 50 milligram, now we need to calculate. Again, from the label, we found 25 milligram is 0.5 milliliters. 50 milligram, I'm carefully putting milligram under milligram, is X milliliters. And now to find my X, I'm going to multiply on diagonal and divide by the third number. And my answer is 1 milliliter. So 50 times 0.5 divided by 25 equals 1 milliliter. In this problem, we also have a label for moisidine and we have an order. Administer moisidine 350 milligram IM now. How many milliliters will the nurse administer? Let's take a look at our label and see what kind of information we can pull out of it to help us solve this problem. And remember, when we need to go from milligrams to milliliters, we are looking for the concentration on the label. How many milligrams are equal to how many milliliters? Let's read the label carefully. There's total amount of 500 milligram. That's not helpful to us. Then it says it's for IM or IV use only. And we have instructions for IV and we have instructions for IM. So let's verify with our order. What is it that we need, IV or IM? The order is intramuscularly. So let's ignore the IV solution instructions and only focus on intramuscular solution instructions. And we read that we need to add 1.5 milliliters of sterile water for injection. We need to shake well to dissolve, and it will provide approximate volume of 1.8 milliliters. And now to the most important part in parentheses, 280 milligram per milliliter. Now we have something to work with. This is the concentration we were looking for. As always, using DKP method, I'm writing what is it do I know from the label. $280 milligram is 1 milliliter. How much do I have to give? 350 milligram. 350 milligram is X milliliters. I don't know how many milliliters. I verify that I have my milligram under milligram, milliliters under milliliters. I multiply on diagonal, that's not an X. I divide by the third number. $350 times 1 divided by 280. And that equals to 1.25 milliliters. That is the answer. Here's our next problem. Administer Zicilin 500,000 units IM Q12 hours. And here's 3 questions. You will reconstitute with how many milliliters of diluent for a concentration of how many units per milliliter, and you will give how many milliliters in one dose. We have a label with lots of information given on the label. Let's read it carefully. We see that this is Zicilin for injection, which is exactly what we need. And we have 5 million units per vial. That's not helpful to us because none of the questions is asking us how many units per vial it is. Next, we keep reading to see that it is for IM or IV use only. And this is appropriate for our order because our order is intramuscularly. Preparation of solution, add 23 milliliters, 18 milliliters, 8 milliliters, or 3 milliliters of sterile water to provide 200,000 units, 250,000 units, 500,000 units, or 1 million units per milliliter respectively. So if I am adding 23 milliliters, I am getting 200,000 units per milliliter. If I'm adding 18 milliliters of sterile water, I'm going to result in 250,000 units per milliliter. Now, I have to give 500,000 units. Which number is best to work with here? I think it's 8 milliliters will be best to work with because it will give me 500,000 units per milliliter. So I can now answer my first question. You will reconstitute with how many mLs of diluent? I decided it's going to be 8. Because 8 milliliters of diluent will give me 500,000 units per milliliter. That's on the label. For a concentration of, and I just said, 500,000 units per milliliter. Give how many milliliters in one dose? If I have to give 500,000 units and 500,000 units is per milliliter, that means I only need to give 1 milliliter. You will find more dosage calculation problems for practice in my book, Dosage Calculations: Getting It Right Every Time.